Ladies and gentlemen, it's time for the next session. Please give a big hand to Gavin King from Red Hat.
Thank you, everyone. So I'm sorry to do a bait and switch on you guys, but I decided yesterday that I'm not going to talk about Jakarta Persistence at all. And so there's going to be a talk about Jakarta Data. So if you came here hoping to hear all about Jakarta Persistence 3.2, I'm sorry you're going to be disappointed, though I am going to mention its existence at various points along this talk. So I'm going to begin talking about the background behind Jakarta Data and why I'm involved in it. And first I have to give an explanation for why the hell I changed my mind about these things which I hated. Repositories have been around for a long time, or under various names, DAOs, whatever you want to call them. And I was always a big skeptic of them. They didn't seem to do anything useful. So first of all, I have to explain what happened to change my mind. And the best way to begin with that is to say how I used to view this, right? So from the point of view of coming from JPA, right? The JPA Entity Manager is a generic repository, right? And it's one defined by a standard with multiple implementations designed collaboratively by the people who had the leading Java ORM solutions at the time, which are still the leading ORM libraries today. And so my question was always, well, what the hell are we gaining here by wrapping this standard, repository in a, and it's a generic repository, right? It's a repository that works for every entity type, right? I didn't like repositories for the same reason that I never liked, writing, book list and author list, back before Java had generics. So what do we gain by hiding this repository behind another one, which is not generic, which is non-standard, which is based on a proprietary framework, and which actually, as I'll go on to argue, provides no additional type safety or extra power beyond what JPA offers, and in fact makes it harder to get at a lot of, or at least some of JPA's capabilities. And the basic way of encapsulating this is, guys, I understand you think this makes it simpler, but if we could have made JPA simpler, we would have. All those operations that are there that are offered by JPA, which makes it look, perhaps more complicated, they have a purpose and a reason, and we didn't just put them there arbitrarily. On the other hand, out of all the thousands of critiques I've read of ORM over the years, many of which I think are quite misguided. The one complaint that really does ring true to me, which I really think is truly a source of some people's bad experiences sometimes with ORM, is that ORM takes you further from direct control over the interaction with the database and over the SQL that's being sent back and forth, okay? And what I want to say is that repositories don't make this better. Repositories actually, traditionally have made this problem worse, right? They don't give you any more direct control. So in particular, the currently most popular repository framework that I'm sure a lot of you guys are using does something terrible, right? It attempts to abstract over JPA stateful persistence contexts, right? So if you think of a Hibernate session or a JPA Entity Manager, it's a stateful object that has a first-level cache of objects that does transactional write behind. So operations don't correspond directly to interactions with the database, operations on the Entity Manager, and it does automatic dirty checking. So updates aren't an explicit operation. You do that by changing your entity. And these repository frameworks try and abstract over that with an abstraction which is based around a stateless kind of interaction, something more like the Hibernate stateless session, okay? And this just doesn't work, right? There's a fundamental deep difference in the programming model between a stateful persistence context and a stateless CRUD type API. Oh, whoop. So, yeah. Second, and I kind of touched on this already, a repository framework traditionally was designed so that each entity type in the program has its own repository. So you have a book repository, you have an author repository, you have a publisher repository. The problem with that is that lots of interesting operations, in fact, most of the non-trivial queries involve multiple entities. And so I'm like, well, where are they supposed to go? Which this query against authors and books, which repository is this supposed to go on? You might think that that's a pretty trivial objection, except that, what am I using these repositories for? They're supposed to be this thing which gives me a better way to organize my code. So if they're getting in the way of code organization, they're not actually helping with that, then that's a significant thing to object. And finally, inspired by Ruby, we have this idea that is well-intentioned. It comes from the idea of we should try and make writing queries simpler. Okay, fine. Where the idea is that I encode queries into the names of methods of the repository. Now, folks, I don't know about you, but a query language is a programming language. I don't like to program in a language with no punctuation, no white space. It's crazy. Look at these, these method names, right, come directly from the documentation of the repository framework which shall remain nameless. All right? I didn't invent these to make them up. They're awful. I want the name of my operations to have something about the semantics of what their role in my program is. Okay? What I really want to do is, you can say, well, okay, fine, great, so go and put that information in a comment there. Okay, but that's backwards. What I want is that in the method name, and then I can put the query into an annotation. And that seems to me to make a lot more sense. So let's not do that. On the other hand, I've just spent probably 5 minutes ranting against this idea, and yet you guys like these things. You guys like repositories. You guys use them, right? I am not, I 100% accept that if thousands of people are doing something, they're doing it for a reason, okay? People don't en masse adopt something and decide to do something for no reason, okay? There is a motivation there, and there must be some value in it, right? So I spent some time trying to understand, why exactly. And here are, maybe you guys have your own ideas about this, but this is what I came up with, right? So I think that some people believe that repositories are going to help them migrate and change between different persistence technologies for various reasons, which I don't quite want to get into here. I think that's actually a false promise. I don't think they actually help very much with that. I think repositories provide a bit of an illusion of type safety. I'm not putting queries in strings in my Java code, right? I'm putting in the method name, which is no more type safe, but there's a bit of an illusion that what I'm doing is a little more type safe, a little more, just programming, rather than embedding a DSL in my program. But ultimately, what I really ultimately came back with, I don't think those are very good motivations, but what I ultimately came back to is, I just think it provides a convenient place to put your queries, right? It's a good way of, it's a sensible way of organizing your code in terms of where do I put my persistent stuff if I want to keep it separate from my more transactional logic. So what if the repository implementation was so trivial and so transparent that it did not get in the way of debugging? So my complaint earlier about this taking you further away from direct interaction with the database, what if we could set it up so that that was no longer true, right? So that these didn't make it harder to debug the code. What if there was no confusion at all between stateless CRUD and stateful persistence context? That's a hard requirement. What if we found a more elegant way to express these kind of trivial, simple queries that we have with that people use this, are doing with query by method name today? And what if the architecture did not restrict how I could organize my persistence operations so that that was something that was up to me? And finally, and most importantly to me, okay, look, guys, this is always the top thing on my list of when I'm thinking about making an API or using an API or changing an API. My number one thing is always, what does this mean for type safety? Okay, so what if repositories actually did make the code more type safe? Why do I care about type safety? Obviously, I want to find my bugs quicker, right? That is the main value that Java offers to me as a developer compared to something else. is that Java is a relatively type-safe language, okay? So I find out about bugs when I compile my code, or IntelliJ informs me about them, rather than having to run tests, okay? The more often I have to run tests, you know how long it takes to run the Hibernate test suite, for example? The more often I have to run tests, the slower I am. It is a massive, running tests is a massive drain on my productivity as a developer, okay? So anything that the compiler can find as I'm typing is a huge win. All right, so if all those things were true, then I would have to be wrong, right? I don't like being wrong much, but you know, if I can be wrong in a positive way, that's great. So the enabling technology here, which made me change my mind, was, you know, really annotation processing. When we sat down, when we figured out that, you know, we could do a lot of cool things by taking advantage of annotation processes. Now, I guess I want to say about this. Some people have a bad opinion, or I've had bad experiences with annotation processes in the past. It's a sharp knife. Like any very powerful language feature, it can be misused. Any language feature which enables metaprogramming enables misuse and enables badness. In particular, there is a way to use annotation processes which actually goes against their intent as part of the Java language. And what we're doing here is not that way, even though a lot of you, I'm sure, have lots of experience with a very popular framework which kind of cheats, which does what it's, you know, not supposed to do. I have no experience with that, with this particular technology. I'm not going to make no comments about it, whether it's good, bad, I have no idea, okay? But what I want to say is that what we're doing here is a lot more conservative than what that one does, all right? Okay. So let's talk about what the solution looks like. I'm going to talk mainly about APIs, but I'm going to talk about, I'm also going to mention at moments how this ties into the implementation. APIs and implementation kind of have to work together a bit. Big disclaimer, I'm going to talk about Jakarta Data in the context of our implementation based on Hibernate, which is called Hibernate Data Repositories. It's for accessing relational data using ORM, okay? Jakarta Data itself is not restricted to anything like that. There are other implementations of Jakarta Data, in particular Eclipse NoSQL has an implementation that is suitable for accessing all kinds of different databases, key value stores, graph data, blah, 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 okay? Don't ask me about any about that stuff. I'm absolutely ignorant about those technologies. So, what does a repository interface look like? First of all, it's just the interface and you annotate a repository. I don't have to extend anything. How do I get an instance of one? If I'm using CDI, I just inject it using the standard annotation. If I don't have CDI and I'm just writing tests or something that's specific that is not standard in the spec, I can just instantiate the generated implementation class like this. So, Hibernate Data Repositories, for each repository interface, generates, as you're typing, right, every time, for me it's command / it generates an the annotation process that generates an implementation of that repository, which you can just look at the code and it's readable, okay? The first kind of thing is an operation which returns an entity. How does Jakarta Data figure out what entity, you know, what the semantics of this query are? That doesn't help. So, first of all, the return type of the method determines a queried entity. Simple, okay? Okay, I'm oversimplifying slightly, but here, it's not that this is a book repository, this is just a library, okay? So in this case, it's just a return type which determines what entity we're querying. The conditions of these fine queries, these are called parameter-based automatic query methods, are determined by the parameters, okay? So here we have string ISBN. This has to match by both type and name a field in the book entity. So what happened? Now you're all looking, well, what happened to the type safety of this? None of you guys believe this is type safe, I can see it. But of course, we're working with an annotation processor, so this is validated at compile time, right? I immediately get an error if that's wrong. If book doesn't have a field named ISBN if it doesn't have, if the type of that field isn't string. Importantly, the name of the method is never significant, right? The name of the method carries no semantics except for your semantics in your program of what it does. You can see here, a second thing, that these two automatic query methods both return different types of entities, right? So my library repository here is encompasses, I have some small little program here. I don't need 1,000 repositories. I can do just fine with one repository. And so I have freedom here. I have the freedom to have one repository per entity. If that's what you guys really love, if you are committed to that, then fine, do it. I can have one repository for all the entities in my program, which is good if I have a small program. Or I can have a repository dedicated to each kind of, group of related entities or some kind of functional way of dividing up my program. I don't know. It's up to you guys, right? This is like, what's that phrase? I've lost it. Let 1,000 flowers bloom, right? So, look, I have all sorts of opinions on how one should design a application, a Java program which does persistence, okay? I have like super strong opinions. Like there is there are people who believe in this thing called domain-driven design, which I think is just, to me, just nonsense on stilts, right? That has no basis in math or empirical science or anything except for one book that one guy wrote 20 years ago. You like it? Great. I want Jakarta Data to be the best way for you to design to create an application using DDD, right? We are not prescriptive here. That's the opposite of, of how we have always approached these problems. So next, what if we want to change some data? Well, here you notice that, once again, we have some annotations. The entity we're updating or inserting can obviously be inferred from the argument of the method. And the thing you're going to notice here is that update is an explicit operation, which is not in JPA, okay? So Jakarta Data repositories, as of Jakarta Data 1.0, are always stateless. They're CRUD-oriented stateless services. This is quite different to JPA. There is no persistence context, okay? In Hibernate, the repositories are backed by a stateless session. You can get at this thing. There is a, what is it called? Resource accessor method is what the spec calls it. So you can, if you need to do something with the stateless session directly, which is, entirely a normal thing to want to do, right? You can declare a method just like that of the repository, and that will give you access, that will return you the stateless session which underlies this repository, and then you can create a default method of the interface where you can do whatever you want to do, right? Explicitly. Now, I've shown you these automatic, what are they called? Parameter-based automatic query methods. Guys, I spent 3 hours talking about quantum yesterday, and I'm like, my head getting it back into persistence is really hard. I can't find words. So we've seen parameter-based automatic query methods, the ones with the find annotation, where the restrictions of the query are these are the parameters of the method. But obviously that only gets you so far, right? So we want also a more flexible query language. You can, as I said, we can go to a certain level with this kind of stuff. Just FYI, in Hibernate data repositories, these parameter-based query methods get mapped to JPA criteria queries. But again, this is just a convenience for simple cases, right? Jakarta Data also comes with JDQL, Jakarta Data Query Language, which is a subset of Jakarta Persistence Query Language. And here, you're going to put the query in an annotation on the operation. And what's wrong with that? Wow, wasn't I just talking about the value of type safety, right? And now I'm putting strings in annotations? You're like, this guy's full of it. I know I am. But in this case, Hibernate is actually capable of building up a model of all the entities in your source path, reading that query, completely syntax and type checking the query against your entities, and producing meaningful errors when as you compile your code. Okay. Even better, IntelliJ actually. IntelliJ actually does it as you're typing, right? Because IntelliJ also supports this stuff. Yeah, there's significant machinery behind that, which took us, literally years to build. So JDQL is a subset of JPQL, restricted to a subset which we think can be implemented on many different kinds of persistence technologies, not just relational technology. So Jakarta Data implementations, which are backed by relational database, have to implement the whole of it, the whole of JPQL, excuse me. But if you're running it's a key value store, you obviously can't implement joins and stuff like that. Hibernate Data Repository supports all of Hibernate query language, which is again a far more powerful language than even Jakarta Persistence query language, and has essentially all the features you guys have ever heard of ANSI SQL and more, right? As of Hibernate 6 and 7, certainly. But what about if the query is more dynamic? Okay, so here I have a query method which fetches the ISBNs of the books, but given it with matching the title. But what if I want to do something more dynamic? I want to do dynamic sorting, for example, right? Or pagination. I want to return some of the query results. So we can add some extra parameters to this method. One is a page request. I guess you can guess what that does. And one is a sort, and I can guess what that does too. And here's how we pass the parameters. Once again, you can see that this sorting parameter is passed in a completely type-safe way. No strings, okay? What do we have here? We have a reference to an element of the Jakarta Data static meta model. So you guys might have used the Jakarta Persistence static meta model. How many people have used that? Nobody? That can't be right. 1, 2, 3. Okay, well, okay, yeah, some people. Okay. So originally, the Jakarta Persistence static method model was something we did to make it easier to write criteria queries. In recent versions of Jakarta Persistence and recent versions of Hibernate, it has taken on a much bigger role. Okay, it is the way to write type-safe code that refers to elements of your entity model. Here's a great example. Except that this is the Jakarta Data static meta model. So now we have two, unfortunately. We have underscore book class. I have an underscore book class and a book underscore class if you're using both of them. I apologize for this. This is not ideal, but it was the best we could actually possibly do. I want to take a little bit of a tangent here. Because it's something that keeps coming up often. I've been asked about this so many times, and so I need to clarify this. Many people have come to me and asked, with Java now having records, can I write my entities as records? Look, guys, I love immutable objects as much as y'all do, right? I like a more functional style of programming in lots of contexts. But to see whether this makes sense for records, we need to think about what records can represent and what it is that we're trying to represent. So mutable types like Java records are great for representing trees. A tree, well, where we don't, join up again. No cycles in the graph. But trees are only a subset of the kind of graphs that you find in typical data. A document database has lots of trees in it. A document is a tree. But relational data isn't made of trees. If I think about the most trivial example that I use all the time, I've used all the time for years, author book, that is a many-to-many association. It is not a tree. And in fact, if you put down on the table in front of me any typical relational data model, you're going to find many-to-many associations all through it. Okay? Why can I not represent such a model with immutable objects? Somebody tell me. Why can't I represent that in Java with immutable objects? You can't. If it's immutable, you can't set up cycles. If it's truly immutable, you can't. There's no way to set the back reference. Okay? Immutable objects aren't for representing relational data. So there are people who advocate representing a relational model as a bunch of tiny little detached islands. They sometimes call aggregates. I'm going to say that this is not how JPA is intended to be used. It is not how I would ever recommend anyone use JPA, and I think it's a mistake, and I think that you all should not listen to these people, okay? These people are not typically people who spend a lot of time thinking about relational data. They're trying to shoehorn a mental model they have, which is based on thinking about document databases or some other kind of data, and they're trying to shoehorn relational data into that, and it doesn't go, okay? My opinion, you can ignore it if you want. You can still use Jakarta Data. That's great, but that's my advice. So while some Jakarta Data implementations will support records as entities, one's backed by a document database or whatever, Hibernate, so where I'm backing in implementation doesn't. We use regular Java classes because that way we can represent all the kinds of relationships that you'll find in a relational database. On the other hand, records make great embeddable objects, and that support is required in JPA 3.2, and Hibernate 6 is supported for quite a while. All right. How are we going for time? Not so good. I was going to do a little well, let's do it, because otherwise people will criticize me. God. Except that's really small, and I don't have my glasses because they broke on the flight over here, and so let's not do that. Okay, no demo. I apologize. I don't like seeing people writing Java code on stage anyway. I don't know what anybody gets out of that. Okay, you can code Java. Yeah, I believe you, man. So let's talk about. I apologize. No, seriously, my glasses broke, and it's really tiny, the letters. I'm a clown show. So let's talk about Jakarta Data 1.1, which is currently in development. And we have kind of prioritized the things that people have asked us about in events like this. And so a very popular request was the ability to observe and react to actions performed by the repository, so an event system. And fortunately, we had this thing called CDI lying around, which has an event system that was designed years and years ago. I don't know how many people use it, but it turns out to be just perfect for us here. So in this little code snippet, you see what a CDI observer method looks like. It's a method with a parameter annotated observes. That's an annotation defined by CDI. It has, and then it accepts an event type. That post to insert event class is a class defined by Jakarta Data 1.1, not available in Jakarta Data yet, though I have actually implemented this already. And with book as the type argument. And so this method will be notified when you insert a book, okay? Now, when I first proposed this design to the group, I was like, okay, the problem with this is that, what happens, we're still going to get notified even if the transaction ultimately ends up getting rolled back. So I kind of went looking in CDI and I came across this thing on the observe annotation called where during equals, and I was like, wow, wait, this looks like almost the thing I'm looking for, right? So I clicked through in the Java doc, and I found my own author tag staring back at me. And so back in 2008, apparently, clairvoyant man, apparently I anticipated that in 2025 I was going to be needing the ability to process events in the after transaction stage. And so I somehow snuck that into the Java EE 6 probably platform. And it sat there for the last 15 years with me having completely forgotten about its existence. And so this is perfect, right? It's just absolutely perfect for what we're trying to do. You can observe things during the transaction completion lifecycle. The second thing that people have asked about is about, we've already seen how to programmatically order the query results, right, with this sort object and using a static meta model. So what about programmatically restricting query results? Well, what we're in the process of, this is non-final, but it's already in GitHub. It's non-final because it turns out I'm the sticking point because I have this personality characteristic where I always want to do everything different to everyone else. And so, but this is what it looks like right now. So we can pass in a restriction object, and we can get them from the static meta model. So here's an example where we're passing in both a dynamic restriction and a dynamic order. We can do things in a little bit more, this lets us do things in a little slightly more semantic way. We can use contains instead of using, there's a bunch of, useful little helper operations there. I can pass in multiple restrictions. It's also important to be able to do projection. So what's projection? Projection is where I return, instead of returning an entity from my query, I return a little object with a subset of the fields, and maybe I want to externalize this. Maybe I want to treat it as like, I don't know what people call these things these days, but DTO, because I'm old, is what I'd call it, right? And so we are currently working on the design for that. What it looks like right now is, if you can see past all those arrows flying everywhere, I define a record with some fields on it. Obviously, once again, I'm going to want those to match the entity fields. I'm going to have to explicitly specify the queried entity in this case, because I can no longer infer it from the return type. This is now this is not an entity type. And then we're going to automatically map the fields of the entity to the constructor of the record type. We can, in cases where this fails, we can also, explicitly specify the mapped entity fields using an annotation. Once again, we're making use of the static meta model to refer to fields of the entity. So what's next? Here I'm just going to kind of speculate a bit. None of this is, I don't have the right to promise you guys any of this, but it's things I'm wondering about, and I think it would be nice if we were able to do these things. So we obviously would like to make it easy to get a lot out of JPA when you're using Jakarta Data, but we also need to think about the opposite point of view. We want to make it easy to make Jakarta Data, to implement Jakarta Data based on a JPA provider, JPA implementation. For example, there are currently multiple implementations of Jakarta Data which are targeting Hibernate as the backend OR mapper. There are 3, actually. Now, for me, I don't have a problem. I can hack in a new operation into Hibernate's APIs whenever I need it, okay? But for the other groups, they don't have control over Hibernate. And so it would be great if JPA itself, the Jakarta Persistence API, offered the operations that someone needs in order to be able to implement Jakarta Data. Really, ideally, you shouldn't have to use any non-standard features of Hibernate to implement Jakarta Data. And so this comes back to this thing which, really, we've known for years that JPA needed a stateless entity manager. If there's anything, I regret as having been slow on and not promoted enough, I think really it's the fact that, the fact that Hibernate has had this stateless session here for years and years and years, and we never really finished it. It always had semantics were a little bit not quite perfect. And more than that, we never told people that they were actually allowed to use it. And it was never in JPA. So people who are in around the JPA, reached immediately for stateful persistence context without even realizing that there was an alternative, okay? And I think for a lot of people, there are a lot of people out there who dislike ORM for the pure, and I would say for the pure and simple matter that they just don't have direct control over, insert, update, delete, okay? And that JPA does a little too much. I don't want to say that it's bad. Stateful persistence contexts have all sorts of, good properties, and I would say probably the majority of Java developers like stateful persistence contexts. There is a minority who do not, and they would be much better served by a stateless entity manager. But not only that, there are some use cases within a single program where you might like to switch from stateful persistence context to a stateless entity manager. So in JPA4, I'm proposing to call this thing entity agent. Why entity agent? A bit out of nowhere, right? Well, the other thing's called entity manager. And we want something that's a little bit more hands-off than entity manager. It doesn't manage the entities, right? So what's more hands-off? I guess it's an agent, right? If you guys hate it, then yell at me and maybe we'll try and think of something better. But I like it. It's grown on me, you know? Get used to it. Give it time to percolate. So on the other hand, Jakarta Data should, and this was something that just simply, missed out from Jakarta Data 1.0. Jakarta Data itself should allow you to have repositories which are backed by stateful persistence contexts. Okay, and that doesn't mean trying to abstract over the two things. It means introducing a new set of annotations, which aren't at insert, at update, at delete. They're at persist, at merge, at remove, at refresh, at lock, the fundamental operations of the Jakarta Persistence API. Okay, and then we could have a repository which is backed by a stateful persistence context. Beyond that, there is an issue. I'm not advocating to add this to Jakarta Data at this point in time, but there are people who are using reactive programming, especially in the Quarkus community, and they use this thing called Hibernate Reactive, which I don't even know how well known it is, but Hibernate Reactive is an ORM solution which is based on reactive streams. Okay, so it is a completely reactive, non-blocking way to interact with a relational database. It does not use JDBC. Everybody assumes that I'm talking about something which are fundamentally under the covers of JDBC. It is not. Okay, it's using something called the Vertex SQL clients, and it's completely non-blocking. Okay. And so this leads us to consider, this is particularly important for, as I said, for people using Quarkus. This leads us to consider the idea of reactive repositories. And what does a reactive repository look like? Well, it just looks like that, right? The return type, instead of this operation, instead of being book, is a uni from mutiny. Okay, so that's a reactive stream, or the head of the reactive stream or something. And so all the operations simply return uni. But this works in Hibernate data repositories today. I don't know if it's worth bringing, formalizing it in the spec, but it's useful. Finally, we have this issue of the query language. So I said that JDQL was a subset of JPQL, and there's a problem with that. So Jakarta Data is completely dependent upon Jakarta Persistence to provide it with its query language. But Jakarta Data doesn't depend upon Jakarta Persistence. It doesn't even depend upon relational databases. And Jakarta Persistence is 100% relational data. So that's a bit wrong. We had this, back and forth, between the two groups as we were working on this, on Jakarta Persistence 3.2 and Jakarta Data 1.1 to try and say, okay, we need, Jakarta Data needs this from JPQL, blah, 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 okay? So that's imperfect. And so we're proposing to move the definition of the query language out into a separate specification, which will provide, kind of two levels of compliance as we have today. And this would be a new top-level Jakarta project called Jakarta Query. This has not been completely approved yet, but we believe that everyone's in support of it, and we haven't heard any negative feedback, so I believe this is going to happen. I believe we should have time for questions, which is great. 10 minutes, perfect. So, yes? In JPA, we have specifications. No, JPA doesn't have that. No, JPA has nothing equivalent. You might be thinking about something that's provided by a framework you're using. Yeah, it's an interesting question. It is an interesting question of whether we have this game. We have this game of what belongs in Jakarta Data, what belongs in Jakarta Persistence, and if something belongs in both of them, then where do we put it, right? Do we put it in, does Jakarta Query start growing some API stuff? Like I could almost imagine the restriction stuff making sense in Jakarta query, but that's not, I don't think that's going to happen. Does it make sense? Would it make sense for Jakarta Persistence to have some kind of restriction API? It actually would, and you know, I've already implemented an API like that for Hibernate, right? But I am not currently proposing to add that to JPA. I hope that answers the question. Sorry, it's imperfect. It's these, you know, balancing act we have to do between something that's very specific to one technology and one thing, and this other thing which is not. Yes? Aha. No, I mean, Juke is this. So the question is about Juke, which is a like a way of building. I don't like. It's not my thing. So I hope I'm not mischaracterizing anything here. It's a way of writing SQL queries using I always get this the wrong way around, an internal DSL. Okay, so. So it's an API where you can build a SQL query in a somewhat type-safe way. So, first of all, does that compete with anything we're doing here? Absolutely not. You know, you can use Juke to write your native SQL query for JPA, right? You could use it, you know, within a default repository method. Okay, so there's no competition there. My take on Juke has always been that I prefer to write my SQL in SQL, not in Java. Okay. So you saw, for example, how we're embedding JPQL queries, or, well, that were JPQL queries in annotations. And I said that, you know, and I was going to demo it, but I can't see what I'm writing. And that's completely type safe, right? Like I can show you, like the author, it's auto completion, it's, you know, errors as you're typing, everything. The I don't know, the whole luncheon or whatever. That's not the expression, but something like that. So would I prefer to then go to something that's like a more verbose internal DSL rather than just using the language itself in an annotation and getting everything? And no, I prefer to write my SQL in SQL and my JPQL and JPQL. Yes? Yeah, so, okay, so there's so I should, 100%, I should qualify that, right? There is the case of dynamic restrictions and dynamic sorting, where 100% you need some sort of API. Yes. Yeah, I mean, to the extent that Juke makes it easier to do that, then, you know, that's great. I have nothing, I mean, I have no, I can't think of words today. I have no wheelbarrow to push, that's not it. Cart to push, I don't know. Come on, you guys must have more questions. Yes? How does which relate to?
Jakarta Data. How does it relate to Jakarta Persistence and JPA?
Jakarta Persistence is just the new name for JPA. Right. Okay? So Jakarta Data does make some small references to JPA, but it is defined independently of Jakarta Persistence. Okay? Yes, JPA, Jakarta Persistence are the same thing. Yeah. Okay? Did I say the wrong words? I might have. Happens. Jakarta Data is what I was meaning to say, is defined completely, there's two things, right? As of today. Forget about Jakarta Query, that doesn't exist yet. Jakarta Persistence is JPA. Jakarta Data is a specification for repositories. These repositories might be backed by a JPA implementation, or they might be backed by something else, right? It's not even true to say that our implementation is backed by JPA really, because really it's backed by a Hibernate stateless session, okay? So from a certain point of view, you could say that, I mean, in some sense, there's sort of no relation, right, as of today. Okay, this was a thing we had to wrestle with when we were writing the spec. Was, you know, to what extent are we going to tie these two specs together at this point. And I argued strongly that we shouldn't, that we weren't ready to, because we needed entity agent, we needed a stateless entity manager in JPA first, and we also and that we needed to keep separate the notion of a programming model for stateful persistence context and a programming model for CRUD type operations that's in Jakarta Data. Okay. All that said, you know, our Jakarta Data implementation is an absolutely trivial wrapper, absolutely trivial. Like I want to show you the anyway, no time. It's like it generates the tiniest little amount of code that just calls the stateless session, and really that is 90%. You know, when you're using Hibernate, you're using 90% JPA annotations to define all your entities and everything. Okay, so you know, and you're writing JPQL queries, so you're actually using 90% JPA. Okay, and what Jakarta Data is offering you is a very, very thin little layer of this helps me organize my code, this helps me make everything more type safe, you know, binding query parameters is now type safe, you know, yada, yada, yada. Okay, my queries now get checked at compile time, all this stuff. Yeah? Cool. I'll probably run out of time at this point. Yes? Yes. No, so that will still work. You know, as I was kind of explaining there, right? Your Jakarta Persistence entities will work with our implementation of Jakarta Data with no change. You just take them and you use them. Nothing to do. You just start running a repository, okay? Does that answer the question? Yes. Oh, yeah, yeah, that was one of the things I was going to show in my demo. Yes, there is an @save annotation in Jakarta Data, which comes with fairly flexible semantics, okay? It says do an update or do a persist, right? It's oh, no, do an update or do an insert. That maps to this, to stateless session.upsert. Thank you for this question. And that maps to a SQL merge. So absolutely there is. Yes, it's the save. It's the @save annotation. Anyone else? I have 3 minutes. That's 2 questions. Come on. Yes. So JDQL does not have joins. But as I said, what the spec says about this is a Jakarta Data repository that is backed by a relational database is required to support all of JPQL. Okay? So that means it looks exactly like what a join looks like in JPQL. In fact, as of JPQL 3.2, you can now write completely ad hoc joins, something you've always been able to do in Hibernate, but which was not actually part of the spec. So you can write them as either association joins, or you can write them as ANSI style, SQL style joins between entities. So it looks like. Obviously that, you know, those kind of more advanced, not advanced, typical, ordinary things aren't available with the automatic query method approach. That's for more trivial things. Yes? I mean, dude. Hibernate, obviously. No, look, I mean, it's very important to me that there be more than one JPA implementation that is viable. I hate, sorry? Good, I am, yeah. So I don't know who's working on a Jakarta Data implementation backed by Eclipse Link, but I wouldn't be surprised that somebody is, okay? Yeah, no, look, there's no point having specs if we don't have multiple implementations of them. To me, it like keeps the, you know, it keeps the competition, it keeps the market, you know, vibrant, right? One more maybe, and then they'll cut off my mic, I'm sure. Nobody? Okay. Thank you very much. I really appreciate you guys all coming.